Okay, spontaneous reactions and what predicts them. What does it mean to be a spontaneous reaction? Well, what does it mean to be a spontaneous person? Who's a spontaneous person? Me, not really, kind of. It means that it's a person who just like up and does things without planning. And a spontaneous reaction is kind of like that. It's a reaction that just up and happens without like having to do a lot to get that reaction to happen. So I think of it as like a natural reaction. It just naturally happens like on its own. It just poof happens. Like spontaneous combustion is like a myth that you can just poof catch on fire and just start burning. The spontaneous part means that it just happens on its own. All right, so there are two factors in predicting whether a reaction will just poof happen on its own, okay? And they are enthalpy and entropy. And enthalpy is a word they don't use anymore. They just call it heat of reaction, which is what you already learned. That was that thing about, did the reaction net energy, was it a positive delta H? Or was there like a net loss in energy, a negative delta H? What was like the net loss or gain, okay? And the positive means you gained energy, so it was endo, and the negative means that you lost energy, so it was exo. Okay, so which one of these do you think would just naturally happen? The one that needs energy put in, or the one that gives energy put off? Okay, so the one that needs energy put in, that's not really going to happen naturally, spontaneously, all on its own, because you have to put energy in to get that one to happen. The one that happens spontaneously is exothermic reactions. Okay, so exothermic reactions tend to happen spontaneously. So negative delta H, exothermic reactions tend to happen spontaneously because they don't take much to get started. Maybe they do take a little spark to get that poof flame, but once they just get activated with a little spark, then they pretty much go naturally on their own. All right, the next part is entropy, and that is a word that they still ask about, even though they don't ask enthalpy anymore. And it is a measure of randomness and disorder, like how disordered is something. So look at this room. Entropy is disorder, so which one is the high disorder room? A or B? Okay, the high disorder room, the high entropy room is this one. Which one is your room? Are you an A or a B? I flip-flop between the two. So this is the high entropy room. So this is the low entropy room. This is low disorder. It's nice and organized. So now we say, well, which one of these would happen like naturally? Which one of these would just happen spontaneously? Okay, so try to think of spontaneously as meaning just naturally, it just up and happens. Well, which one would happen naturally, spontaneously? Does your room spontaneously get clean? No, you have to put energy in to make that happen. Your room can spontaneously, totally on its own, become extremely messy and lots of entropy. All right, so that is the rule. Reactions in nature tend to just naturally, spontaneously go towards high entropy, high randomness and disorder. All right, so that brings us to our rule. What reactions are spontaneous? Reactions which are, so the rule is reactions that are spontaneous. The rule I like to say is they're spontaneous or kind of natural. They happen on their own if they're lazy and crazy. Okay, and you'll see a lot of these reactions. Lazy meaning they just let off all their energy. You don't like put energy in, like they give off energy, so they lose energy. Like if I were to sit in this chair, I'm not going to sit in like a high energy way that's uncomfortable. I'm going to sit in like the least energy play possible. So systems in nature just go towards things that require the least amount of energy. They give off all their energy. And then crazy meaning things naturally in nature go towards disorder or go towards high entropy. All right, so that's going to be a really common question. What do things in nature tend to go towards? They tend to go towards losing low energy, and high disorder. All right, so just think about what things naturally happen or think about lazy and crazy. All right, last thing you need to know is just a few examples of entropy. So for solid, liquid, and gas, which one has the highest entropy? Which one's the most disordered? And solid's super orderly, right? Gas is like crazy. So that's the highest entropy if you're talking about solid, liquid, or gas. If you're talking about a reaction, if you were like, what's more disordered, H2O or H plus O, like H plus O making H2O or the H2O, the side with more stuff, that's more disordered. When you're settled down into a compound, you're more orderly. And the other one is the hotter it is, the more disorder, and that makes